Hi, my name is Stephan, and I'm going into my junior year at the Urban School of San Francisco. My main project is an automatic stabilization gimbal for photography and video making. This here is my first milestone where I was able to get the pitch and the roll motors here working in sync with the IMU. This here is the IMU, which is the inertial measurement unit, which measures the pitch and the roll and the yaw. So basically, it measures where it is in space and time. And what this does is it exports values, and the outputs for this go into the controller here. And this controller here is plugged into the computer, and the computer gives it some power, as well as I'm able to see where the IMU is in time using the brushless gimbal software here. And so on this screen here is the software that runs with this specific board, and here we're able to see a graph, a live graph that's being streamed for the pitch and the roll. So if I was to move the gimbal or the IMU forward, we'd see the pitch dip, and then if I was to bring it back, it would come back to center, and I'm able to make it go up and down. And then for the roll, I can pitch it to the right, and it goes up, and then down to the left, it goes underneath there. And so what I had to do to control this controller over here was I have a specific code here. So for all of these, this here controls the software. This controls the controller, the control panel, another one of the control panels. Kind of another thing over here is the code for the IMU, which measures the pitch and the roll and streams that to the controller, which streams from here. It streams the controller to the software, and this is all for the differentiating all the pins that the two controllers are plugged into. And yeah, that's pretty much it for the code. But what I'm able to do is, depending on how the IMU moves, we're able to see little twitches right now in the motors, which mean that a specific voltage is coming through. And then I'll talk further about that in my demo video. But one problem that I came to when I was doing this was we have the power supply here, and as I increase the power supply, the energy to the motors increases, which means that it's able to move at a more consistent pace. And then I'll talk more about that in my demo video. But one of the problems that we came across was one of the motors isn't really working, and it doesn't move continuously in a very smooth way. And we were able to troubleshoot that because we have a new motor on the way, and we knew that there was a problem with the motor when we switched both the pins from the motor 1 input. So here's the motor 1 input, which is connected here to this motor, and the motor 2 input here is connected to this motor, which is the pitch and the roll motors. So what would happen is, as this would move, one of these would spin smoothly, and the other would kind of hesitate on each one of the coils on the inside of the brushless motor. And then my next video will be a demo where we use the power source and the IMU to control both of the brushless motors.